Hey, great to have you back again. This is Tony Dubio here, Technical Solutions Architect for the Cisco Cloud and Managed Services Organization. Today we will focus on Demo 2, which will include the user interface for Intercloud Fabric Director. This is the area where a user would log in with roles-based access, and depending on their role, they would have access to a particular catalog and virtual machine resources that reside on both the customer premise as well as in a provider cloud environment. In addition to the user interface, we will also take a look at the network interoperability characteristics and how I was able to set up a three-tiered traditional application with a web tier, an application server tier, and a database tier that resides both on the customer premise as well as in the AWS environment, where I've created two virtual data centers, one for web servers and one for application servers. For perspective, this is what I'm talking about right here. Web and application server tier, and we have a database residing on the customer premise. This is the scope of today's demo. With that being said, let's go ahead and log into the user interface. I will be using an account called User1, which provides me with limited access to the existing resources. When we first log in, we see four tabs here. One is a catalog. We'll table that for a moment and take a look at these other three to the right here first. We'll start with virtual resources. So when we go into virtual resources, I'm going to go ahead and click on VM. And what you'll see here is a subset of the virtual machines that were exposed in the administrative console that we looked at in Demo 1. If we take a look here, we can go ahead and organize by the type of cloud. In this case, we have three virtual machines that are currently running in AWS. We have two virtual machines running in Microsoft Azure Cloud. And then lastly, we have vCenter virtual machines, which are running in our private cloud on the customer premise. If you recall, in Demo 1, we migrated AWS Server Primary that happened to be an application server that was already up and running in AWS Cloud. We migrated it back to the customer premise, and we decided to locate it in the private app VDC, which is just a logical construct that represents a virtual data center that I created just for that purpose, to migrate virtual machines back to the private data center. We certainly could have migrated it to the default VDC, which is the area where all of the other virtual machines in the lab were previously running. So in the spirit of moving virtual machines, I would like to go ahead and kick this particular migration off so that it has time to run while we focus on the other aspects of the user interface. So if I select AWS Server Primary, we have our cloud virtual machine lifecycle management options here, one of which is to migrate to cloud. From that, I can select the virtual data center on the cloud side. So we will be migrating this into AWS App Virtual Data Center. It happens to be a CentOS 6.3. And then I have the option to remove the source VM, which deletes the VMDK file and configuration file from my vCenter as part of a cleanup exercise. Obviously, I can continue to keep those files on premise in case I wanted to make a copy or clone them. In those regards, I can maintain that virtual machine, perhaps to create an image. In this example, we'll go ahead and delete it from the vCenter, and I can show you that it is completely removed after we migrate this virtual machine. So we'll kick that off. Now let's take a look at services. From a user perspective, we do have some visibility into the status of virtual machines as they migrate into the cloud. In this case, we'll connect to that workflow, and we can see that the virtual machine is currently migrating to the public cloud provider. If you recall from the administrative console, we had an additional option which allowed us to review the verbose logging. From a user role and access level, we are unable to see verbose logging. We only have this high level status. However, as we refresh the screen, we can see changes. Obviously, when migrating a virtual machine, there's quite a bit of time in converting the files and updating or uploading the VMDK, the virtual disk file. So we won't see a lot of changes here, but we'll check back here in a few minutes and see what percentage we are regarding the actual migration. In the meantime, let's talk about approvals. Approval chain can be implemented into Intercloud Fabric Director. This is a functionality that was ported over from UCS Director, the actual parent product of Intercloud Fabric Director. And if we were to configure approvals, we would see that as part of an approval chain before the actual workflow would initiate. In this case, we haven't implemented any approvals, so whenever we select an option from a cloud virtual machine lifecycle management perspective, the tool set would immediately initiate that workflow without needing any acknowledgement from anybody else in the system. However, we could enforce that option, and then hence we would need to wait for a response before we could move forward. I mentioned that we have a catalog. So if we look at our catalog here, we could have multiple catalogs for a user, depending on who the user is. Again, roles-based access is implemented. That would determine the catalog that is exposed to that user from which they log in. So in this case, we have two templates that as part of my lab, I have uploaded a template being a virtual machine that had a preloaded guest operating system and an purpose-built application. As such, I've created a LAMP stack. A LAMP stack is actually a tool set for developers, for web developers specifically, that has Apache web server and related tools for coding web servers already pre-packaged into a LAMP stack, which is a very common template that is used in public cloud web hosting. I've also created a web server template from an application server that participates with a web server that has been pre-built as part of the Cisco dCloud demo. So I've borrowed that template to use in my environment. And that's what we'll use today to demonstrate the ability to initiate a virtual machine in AWS, which happens to be an image, to create a copy of an application server. I've previously built this template, which was uploaded into AWS and is stored as an AMI image file. Moving back to the admin console for the moment, let's take a look at Intercloud, Compute, Enterprise Templates. These are the actual files that have been uploaded into Intercloud Fabric Director. We can originate the template by either using a BZ2 file or an OVA file. Once we've uploaded the file into the Intercloud Fabric Director, in turn it would then synchronize and update this image to make it available in Prime Network Service Controller, which is a subcomponent of the Intercloud Fabric Business Edition as part of the software suite. Once it's available in Prime Network Service Controller, we can create Intercloud Fabric templates that ultimately provide us with a new catalog entry. Currently, we have two. Again, the LAMP stack for AWS and an application server. These are the two templates that we reviewed from the user interface. If we look in AWS in our EC2 Elastic Compute environment, this is the dashboard and portal that is provided to an end customer of AWS. If we navigate into AMIs, these are the actual image files. From the date, I can see that this particular file here from April 16th was the actual application server template in OVA that I created. And then from a catalog entry, that OVA was converted to an AMI file, which in turn was uploaded into AWS, where it was given this name based off of the default naming convention of AWS. I could rename this file, which was the case here with Web Server A. In this case, I left the default, and I can look at a description to understand that this is actually my app server template. The value in creating these templates is that once this file is uploaded into AWS, it can be powered on and can spawn a copy of the application server quickly in comparison of the amount of time that it takes for migrating an actual working virtual machine and workload from the customer premise into AWS. Obviously, that takes quite a bit of time depending on the size of the VMDK file that ultimately needs to transfer in its entirety from the customer premise over the internet or private WAN link to the AWS environment. With an image and a template, it's uploaded once and then made available as needed when launched from the user interface as part of a catalog. At this point, let's revisit the user interface. Logging in, taking a look at services, and we can see that both of our service requests that we initiated in this demo have completed. We will take a look at this one first, number 80, which was the AWS server primary, and migrating that particular virtual machine to AWS, which has completed. And then we spawned a copy of an application server from a template, which is also completed. If we transition to the virtual resources, looking at the available virtual machines, we have some additional information that we would like to note here. Taking a look at the AWS server primary, we can see the IP address of that particular virtual machine, which is 192.168.11.22. as well as the app server demo that was created from the template as an actual copy of the application server. Template was allocated an IP address on that same subnet that is a part of the application server VDC, the private IP addressing of the customer using the .11.21. This IP address was allocated from an available pool of IP addresses that we created as part of the network policy that we associated with the application server VDC. Now that we have those two available virtual machines, we can take a look at them as well as other existing workloads that we have. Let's go ahead and organize our clouds together. So if we're looking in AWS, we also have the web server. So we'll take a look at the web server. This is the public IP address, the NATed IP address in terms of public facing capabilities of AWS. And then we also have the enterprise IP. So this connection over the tunnel should be reachable from my virtual machine that we are connected to that is functioning as a jump box. That is also on the 192.168.10 network. To validate, we can see that we have a 192.168.10.40 private IP address as part of the enterprise private cloud, and we should be able to ping across the tunnel to 192.168.10.101, which is the web server. To go a step further, let's now ping the IP address of the application server demo that we spawned in AWS. So ping 192.168.11.21. Again, this reachability is across the secure tunnel between the private cloud and AWS. And to take it a step further, let's go ahead and SSH into that application server. So allow me to bring up a session here, a new session. We're going to go to 192.168.11.21. Accept the public key. Okay, so we've logged in. To point out something quickly here, the actual private IP address, tenant private IP address that's allocated as part of an AWS customer EC2 VPC, this 172.31.40.66 is the actual IP address that has been allocated to a VNIC as part of the hypervisor that is hosting this particular virtual machine. As we take a look into the networking, we can see that we also have a VNIC that represents the VPN client that maintain the customer enterprise private IP address, in addition to the AWS private IP address, which is the IP address in VNIC that is NATed to create that public IP address that was the 52 dot something or another. So let me move this out of the way. So app server demo has a public IP of 52.7.74.156 that is a NAT translation for 172.31.40.66. If we do an if config, we can see these assigned VNICs. So CSC 0 is actually, again, that AWS private IP, tenant IP of 172.31.40.66. And then we have Ethernet 0, which represents the VPN client that encrypts this virtual machine to every other virtual machine in the customer's tenant environment in AWS that is a part of the bubble, or what we call the secure shell. That abstraction and that secure wrapper around the private cloud that has been extended into AWS, in this case into the application virtual data center. We have 192.168.11.21 represented here as part of that abstraction. Now let's show a proof point that routing is actually functioning within AWS using our CSR Lite functionality from the Intercloud Fabric Router component. So I am on an application server that is a part of 192.168.11 subnet. I'm able to ping across VLANs locally. So the web server that we looked at earlier is 192.168.10.101, and I'm able to ping the web server from another VLAN that is routable within the tenant environment. If we execute the ARP command, we can see both of our gateways. We can see our private IP address gateway that we connect to on Ethernet 0, as well as our gateway within the AWS tenant environment as part of that VPC that we connect to on CSC 0. So these are the MAC addresses of those routers. At this point, I'd like to summarize what we've discussed in Demo 2. Again, we've looked at the user interface. We've leveraged a catalog to instantiate a net new copy of an application server. We were ultimately able to connect to that application server and demonstrate the ability to route between VLANs within AWS, between the web server tier and the application server tier that are represented as part of a virtual data center that is routable because we have an Intercloud Fabric router that is configured as a virtual appliance to route between VLANs to localize routing within AWS. We've also looked at the ability of using the user interface to migrate an existing running virtual machine, which was the AWS Server Primary from the customer's enterprise data center and private cloud into AWS. We looked at the ability in terms of what the user has access to from the services tab versus the verbose logging that is available from an administrator as part of the administrator console and the tool sets that are made available to an administrator based on roles-based access versus a user. Why is this all important? Because connecting to AWS or any other public cloud provider without Intercloud Fabric Business Edition is really a huge pain in the ass, because when configuring IPsec site-to-site tunnels and having to as a customer, having to configure your own NATing and your own routing and trying to patch together your private IP addressing with the IP addressing that is allocated as part of a private VPC and Elastic IP. All of that integration and that configuration is manual, and it's a responsibility of the customer. With Intercloud Fabric Business Edition, we automate the provisioning of the virtual appliances that are needed to orchestrate the tunnel, as well as securing the VMs and extending your private IP addressing to make interoperability and internetworking with that private tenant VPC environment very easy and seamless to the customer as it is executed as part of policies and templates that are provided in the Intercloud Fabric Director. Thank you for watching this demo, and stay tuned for the next demo, which will focus on Microsoft Azure with interoperability and federation into an AWS cloud, so multi-cloud use case, as well as extending a SQL server that has been consumed from the Azure Marketplace and implement it outside the scope of Intercloud Fabric, or the secure bubble and secure shell environment, where we will demonstrate the cross-connecting capabilities of using the tenant IP address and that second VNIC to pull in services and make them interoperable with VMs that are running in Intercloud Fabric.